Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Two keys keyboard, Leetcode 650. In this problem, we are given a notepad with only one character A on it, and then we can perform two operations on this notepad. One, copy all, with which we can copy all the characters present on the screen. And second operation is paste, with which we will paste all the copied characters. And the copy cannot be partial, so that means whatever is on the screen, we will just copy it. Then we are also given an integer n, and we should return the minimum number of operations needed to get n A characters on the screen. Then they have given some examples as well. So for example, with n equal to 3, we can see that we initially have character A. Then in step 1, we will do the copy all operation. Then in step 2, we will paste it. So we get AA, and then we paste it again, and we get AAA. And once we have displayed 3 A characters, now we will return. And because it took 3 operations, we will return 3 in this case. Let's take a little more elaborate example. So suppose n is equal to 6. So first operation will always be copy operation, right? Because without that, we cannot even paste. I've denoted copy with orange and paste with green. So first we do the copy operation. So one option can be after copying, we do paste. So we will get AAA. Then we paste again 3 times. So we will get 6 A's. So this takes total of 1, 2, 3, 4, 5, 6 steps, right? Another option can be that after getting 3 A's, we can do a copy again and then paste again. So that will again give us 6 A's. So in this case, the number of operations will be 1, 2, 3, 4, 5. So because 5 is the minimum, so we will return 5 in this case. Now, in terms of solution, there are multiple solutions possible. One possible solution can be that we recursively calculate the minimum operations required with this kind of a decision tree. We can assume that at each step we have some correct characters displayed on the screen, and we have some value in the clipboard as well. Then we can perform two operations. One, either we can do copy and paste. So when we do copy, our clipboard is equal to current. And when we do the paste, then our current size doubles and our clipboard is now equal to current, right? So that requires two operations. Or we can just paste. In this case, our current size will increase by the clipboard length and our clipboard stays the same. So for example, if we had AAA on current and AAA on clipboard, then when we do copy paste, our current will become AAAA, that is 6 A's, and our clipboard will be equal to 3 A's now, right? But if we do just the paste, then our current value will become 5 A's, right? And clipboard value stays the same. So we will only have 2 A's on the clipboard in this case. But main thing is, like, when we perform these operations, each of them have some cost. On the left side, we can see that number of operations are 2, that first we copy and then we paste. Similarly, on the right side, we have only one operation. So based on this, we can define our recursive function, which takes current value, say I, and clipboard value, say j. So let Fij represent the minimum number of operations needed to generate n A's, starting with I A's currently on the screen and j A's in the clipboard. So at each step, we can perform these operations and count number of operations we have got so far, and the minimum of these will be our answer. And then we have two base case. One way can be that we have reached n, then that means we should return 0 because we don't have to do any more operations. So we will just return 0 in this case. Or we have more than n characters, that means we have overshot. So for example, if our n was equal to 5 and we already have 3 A's on the screen, then if we do copy paste, we will get 6 A's. So that means we have overshot. So in this case, we can return some large number like integer.max value or something to signify that cost of this path is infinite or super high. But note that in our problem, we are given n is less than equal to 1000, right? And we know that in the worst case, if we do just the paste operations, then number of operations we will get is equal to n, right? So in this case, we can take our maximum value equal to 1001 or something. Now let's look at it with some example. So let's again take n equal to 6. So initially we are given 6 characters. Without copy, we can't do the paste operation. So our first operation always has to be copy, right? So suppose for this, we have already taken one operation where we have copied the character, and now we have one A shown on the screen and we have one A copied on the clipboard with just one operation, right? So if we take two operations, that is we do copy and paste, then we will get 2 A's on the screen and 1 A in the clipboard, because we had 1 A on the screen, and when we do copy, our clipboard's value stays the same. but when we paste, we will have 2 A's on the screen. Then we again do the copy paste. Now our number of operations will be equal to 4, and our screen now has 4 A's and clipboard has 2 A's coming from 2 A's from the previous screen. Again, if we go with the same process, then even though number of steps will be equal to 2, but we can actually still return infinite because now we have 8 A's, but we wanted only 6 A's, right? So we have overshot. So we will return infinite in this case. And now we return back, and in another path, we just do the paste operation. So then we get 6 A's on the screen, which is what we wanted. And number of A's on the clipboard stays 2. So then our number of operations here will be 2 plus 2 plus 1, that is 6, because we are counting this first copy operation as well. So we got 6 A's from this path and it took 6 operations, but we don't know if this is the minimum number of operations. And note that on the right side also we have a similar tree, but with one operation less, because we just do the paste operation and we still get 2 A's on the screen and 1 A in the clipboard. So in terms of decision, we will choose the recursion path on right as it has minimum number of operations, and I showed the left side of recursion tree mainly for demonstration. Then on the right side, we can see that we will follow the similar operation that we had here. So we got 8A and 4A, so it was infinite. Similarly, here we can see that last time on the left side, we got 6 A's on the screen and 2 A's on the clipboard, but with 6 operations. But here it takes one operation less, so it takes 5 operations. So first we did copy, that takes one operation. Then we did paste, that takes another operation. Then we do copy and paste, so that takes 2 operations. And this gives 4 A's on the screen and 2 A's on the clipboard. And finally we do the paste again, that takes one operation and gives us 6 A's on the screen, and that is the number of A's required on the screen. So this is how we get 6 A's on the screen through 5 operations on this path. Similarly, we will do the same thing on the right side as well. So suppose we had AA, then we did paste only, so we got 3 A's and 1 A. So then we did copy paste, so that again got us to 6 characters, even though our clipboard now has 3 characters. So in terms of operation, again it took 4 operations plus 1, so overall 5 operations, but we don't know if it's minimum or not. So we will continue with our recursion, and finally we will get the minimum number of operations to reach 6 A's on the screen as 5. Now let's jump into the code part. So in terms of recursion, our first step will be that we will do the copy operation, and then we can define our helper function. And in the first step, we will pass 1 as the current length because A is already shown on the notepad. Then 1 on the clipboard as well because we just did the copy operation. And N is our target length. Let's define our function now. We will return minimum number of operations needed to generate n A's, given I A's on the screen and j A's on the clipboard. So current length denotes number of A's on the screen and clipboard length denotes number of A's on the clipboard. And this is our target length. And our first base condition is if our current length is equal to n, that means we have reached our goal. So no more operations are needed. But if we have overshot, then we should return infinite or some large number to signify that this path is invalid. So I am taking infinite as 1001 because of this constraint here. So if our target length is n and we do all the paste operations on character A, then it will take n operations to reach target length n, and n at maximum is equal to 1000. So 1001 should be a safe infinity value. Then we have to explore two possible operations, copy all and paste, or paste only. So let's first do the copy all and paste operation. So that will require 2 operations. Plus we will call the helper function with double the length as we have doubled the characters on the screen. And our clipboard is now equal to current length and our n stays the same, of course. Or we can do the paste only operation. And this requires one operation or one step. We'll call the helper function again now with current length plus clipboard length. So whatever was on the clipboard, we just paste it, and clipboard says the same. We will pass n as is. And finally, we calculate the minimum steps required by taking minimum of the results from these two operations. So we will take minimum of copy and paste operation or paste only operation. Also, if n is equal to 1, then we require no operations. So we should return 0 because in the start we already have A on the screen, right? Otherwise, we start our recursion with the copy operation. So we will have 1A on the screen and 1A in the clipboard. Now let's run this code. Yeah, I should be passing clipboard length, not clipboard. Yeah, let's run this code again. Sorry for the typo. Cool, let's submit this code. As you can see, this solution got accepted and it beats 40%. This is surprising to me because our time complexity is O of 2 to the power of n, where n is the target number of A's we want on the screen. And the reason is at each step we have two choices, either choose copy all and paste operation or choose paste only, and we choose minimum of them. So this is why our time complexity is 2 to the power of n. In terms of space complexity, it is O of n because we are using the recursion stack. But now let's try to improve this. So if you remember this diagram, there we can see that we are seeing the same subproblems again and again. So for example, left and right subtree are almost same. So to avoid recalculation, we can use top-down dynamic programming with memoization or caching. Let's define 2D array cache to store intermediate results. Let's initialize it to size n plus 1 into n by 2 plus 1 for current length into clipboard length. Because our current length can go from 0 to n, so that's why we get n plus 1 rows. And our clipboard length can go from 1 to n by 2, right? Because if we double the clipboard size n by 2 in case of copy paste operation, we will get number of A's on the screen as n, right? And that's our goal state. So clipboard length cannot exceed n by 2. So that's why our cache size is n plus 1 into n by 2 plus 1. Now before diving into recursion, we will check if the result for the current state is already in the cache. If it is, we return the cache value, eliminating the redundant calculations. Otherwise, we will continue with our recursion and store the minimum steps required for the current state in the answer and cache it for the future reference and return answer. So now let's run this code again. Okay, I should be doing new int. Now let's run this code again. Cool, let's submit this code. Awesome, now it's even better. And in terms of time complexity, it will be O of n square, because if you think about it, our cache size is equal to literally O of n square by 2. So we have to just fill in this cache. So that requires O of n square. And in terms of space complexity also, it is O of n square because we are using this cache that takes O of n square. And we are also using recursion stack that takes O of n. So overall the space complexity is O of n square. And now let's move to bottom-up dynamic programming approach. We have already seen the recursive approach. We can also convert it to bottom-up dynamic programming approach that will require O of n square in terms of time and space. And I have covered that solution on my blog, but we can optimize our dynamic programming approach and make our solution easier as well. Let's take n equal to 50. That means we have to find minimum number of operations to get 50 A's on the screen. And suppose we already had 25 A's on the screen. Then how many operations will it require? It will require one copy operation and one paste operation, and voila, we will get 50 characters on the screen, right? And the question is why we have to paste only once, because there were 25 characters already on the screen. So to get another 25, we have to just do the paste operation. So if you write it mathematically, then we do 50 minus 25 by 25, that is 1, which is also equivalent to 50 by 25 minus 1. So we get 2 minus 1 equal to 1. But we assume there were 25 characters on the screen, right? Now let's take our answer for n equal to 50, that is minimum number of operations required to get 50 A's on the screen, be x. Then x will be equal to 1 plus y, that is one copy, one paste, and y. And what is y? Y is minimum number of operations needed to get 25 A's on the screen. And now let's try to derive y in a bottom-up way. Now we want 25 A's on the screen. And what is the efficient factor or number of A's on the screen which can result in minimum number of operations, where we can just multiply or catapult number of A's to 25. Let's try to find it out. Let's take 25 by 2 first, that is 12. Because if we do the copy paste, that will give us 25 A's with only 2 operations, right? And that will be the minimum number of operations. But 25 is not divisible by 12. So because of this, if we do copy paste operation, we will get 24 A's on the screen and our clipboard will have 12 A's, right? So if we paste again, we will get 36 A's on the screen. That means we have overshot. So if we have 12 A's on the screen, then either we will be below the target, that is 24, or we will be above the target, that is 36. So we will not get 25 A's at all. So now let's try out the next number of characters, that is 11. So that is also not dividing. So similarly, we will go till 10, 9, 8, 7, 6, 5. And finally, we can see that 5 is actually dividing 25. And why division is important? Because if we have achieved a certain number of A's on the screen, Then the optimal way to get number of A's on the screen is by copying and pasting chunks compared to pasting single A's repeatedly. So this is what we are trying to do. So now if we have 5 A's on the screen, we can do one copy operation plus 25 by 5 minus 1. That is 4 paste operations because we already have 5 A's on the screen. So we have to paste just 4 times. So this will give us 5 operations in total. So if you have 5 A's on the screen, that will require 5 operations to get 25 A's on the screen. And now suppose to get 5 A's on the screen, it required Z operations, then our Y will be equal to Z plus 5, right? And eventually we can check that to get 5 A's on the screen, it required 1 copy plus 4 paste operations. So in total 5 operations. So Z will be equal to 5. So if Z was 5, then Y was equal to 10, and then eventually X was equal to 12. So that is why it required 12 operations to get N equal to 50. And coding this is not that hard. So we can start with maximum possible factor, that is N by 2, and see if it actually divides the number. And if it doesn't, then we find the maximum factor which actually does divide the number. And then we do one copy all operation and N by factor minus 1 paste operations, and we will continue doing it from the number equal to 1 till given N. So now let's jump into the code part for this as well. So because we are filling in bottom up, we don't need infinite or cache or anything. We can still keep our base case. And now we create the DP array of size n plus 1. The base case for this DP will be DP1 is equal to 0 because initially we already have one A character on the screen, so we don't require any operation. And now we will start filling in the DP array by looping from 2 till n. Initially we can set the DPI equal to I for one copy and I minus 1 paste operations. So that is a maximum number of operations to get I A's on the screen. And now we will try to find the biggest factor j of I. So initially we will try the factor j equal to I by 2. But if it is not a factor, then we reduce it by 1 all the way up till 1 like we did for 25. So we went from 12 to 11 to 10 to 9. So then we will check if the number is divisible by this factor j, then number of operations for I will be whatever was dp of j. Note that dpi denotes the minimum number of operations required to reach the number I, right? So similarly, dpj is the factor of it. So we will just require minimum number of operations to reach j plus 1 for copy plus how many times we have to paste? We have to paste I by j minus 1 time, right? Of course, 1 and minus 1 will cancel out, but I'm just writing it out for the clarity. And once we have filled in the value, we will break out of the loop and fill in the remaining DP array in the bottom up manner and return DP of n. So now let's submit this code. Awesome. In terms of time complexity, it is again O of n square because we are running these two nested loops. And in terms of space complexity, it is O of n because we are just filling in DP array of size n plus 1. So that's it for today. I hope this video was useful to you. If it was, please like and subscribe. The code link with various solutions, including the solution using prime factorization, is also available on the blog. Please check it out. Feel free to leave any questions or suggestions in the comment below. Until next time, happy coding.